The last two skills from section 4.3 are review of geometry skills. So the first application here is the typical ladder leaning against the building. And I want to know how high up is the ladder going to reach. And we're given a couple of pieces of information. We know that with respect to the building, the ladder is going to form a 78-degree angle to the ground. So we know in here it's 78 degrees. And I know the ladder itself is 8.6 feet. And the question is, how high up the building does the ladder reach to the nearest tenth of a foot? So I'm trying to solve for x here. This is the situation we'll use our geometric definition of our trig ratios. I'm giving you the opposite side and the hypotenuse side. And the relationship that we know that is opposite over hypotenuse is sine. So the sine of theta is opposite over the hypotenuse. We know that theta is 78 degrees. My opposite side is the unknown, and my hypotenuse is 8.6. And so I go about solving for x, which would be multiplying both sides by 8.6. So 8.6 times the sine of 78 degrees is going to give me 8.4 feet to the nearest tenth of a foot. If I didn't have the angle measurement, that's where I get into using the inverse sine, cosine, or tangent. So just as a quick review from what you had in geometry, if I had a triangle and I had an adjacent side of 2 and a hypotenuse of 5, and I wanted to know what that angle measurement was, I would look at my relationship and I would say I've got the adjacent over the hypotenuse, and I know that's the cosine. And then in order to solve for theta, what I did is I used cosine inverse. So cosine inverse of 2/5 is going to give me the angle measurement of that triangle, which in this case is going to be about 66.42 degrees. So that's how I use the inverse. This -1 up here indicates the inverse. So if I want to find an angle measurement, I'm going to use the inverse. So I've got two situations here, one being tangent, one being cosecant. And I want to know what is the value of theta in radians and degrees using the calculator of these two decimals. So I'm asking myself, what angle created my given value? And I'm going to use sine inverse, cosine inverse, and tangent inverse. So for this one, I want to know what angle measurement created 2.3545. So I'll pull out my calculator, and I need to do this in both radians and degrees. So since I'm in degree mode, I'll start by doing tangent inverse of 2.3545. And I get my degree measurement is 66.988 degrees. I can then do the same thing using the radian measurement, changing my mode to radian, and then entering the exact same expression again. And I can recall my previous expression by hitting second and then the enter key to bring up my last entry. So now that I'm in radian mode, I can see that I'm 1.169 radians. If I didn't have a calculator but I had the degree measurement, I could always use the relationship that there are 180 degrees in pi radians and solve that way. The second example here is the cosecant of 1.1547. Now if you look at your calculator here, we only have three inverses: sine inverse, cosine inverse, and tangent inverse. So I need to use one of those three functions in order to solve for cosecant. And if you think back to your identities, we know that the cosecant of theta is the same thing as 1 over the sine of theta. So I'm going to use the relationship that sine and cosecant are reciprocal relationships. Now, here's something that we have to be careful that we do not do. The reciprocal relationship is with respect to the function. And here I'm trying to take an inverse. So what I cannot say that the cosecant inverse of theta is the same thing as 1 over the sine inverse of theta. This is completely wrong. We cannot take a reciprocal in that format in terms of our inverse. What we need to do is we need to flip our value inside the inverse function. So, for example, if I had the cosecant of theta equals some relationship a divided by b, that would mean that if I'm going to be using the sine value, I'm going to take the sine inverse of b over a. I've got to do the flipping inside the sine inverse and not put the sine inverse over 1, or 1 over the sine inverse. So for this expression right here, the cosecant of 1.1547, I know that I've got to use sine inverse, but I am not going to put 1 over the sine inverse of 1.1547. So here, the cosecant of theta is equal to 1.1547. I've got to use the sine inverse function on the calculator. So this is going to be sine inverse of 1 over 1.547. Notice that I did the flipping inside the sine inverse function and didn't just put 1 over the sine inverse function. And if I solve that out in degrees, I get 60 degrees. And if I do it in radians, I'll get 1.047 radians.